Section 4.2 deals with experiments. I know you do experiments in your science class, but I want to make sure that you understand in statistics what we mean by an experiment when we say an experiment. ADHD is linked to, let's look at an example. ADHD is linked to lead in mothers smoking, an article by Karen Barrow in 2007. A study performed by Karen Barrow. A mother is smoking during pregnancy and exposure to lead significantly increases her child's risk for developing ADHD. Researchers say, in fact, as many as 1/3 of cases of ADHD are linked to exposure to tobacco, smoke, and lead before birth, giving moms another reason to quit smoking during pregnancy. For this study, researchers from the Cincinnati Children's Hospital surveyed almost 5,000 kids between the ages of 4 and 15. Over 4% of the children had ADHD. The researchers found that those children whose mothers smoked during pregnancy were over twice as likely to develop ADHD as a child whose mother had not smoked. Okay. So based on this study, we cannot conclude that smoking during pregnancy causes an increase in the likelihood that you develop ADHD. Explain. So in the past, I'd left this as an open-ended question. Do you think this article proves that smoking causes ADHD? And usually kids will kind of say yes. The idea here is that they didn't run an experiment. This is not an experiment. This is just an observational study. They took 4,700 kids. They observed whether their parents smoked or didn't smoke. And then they looked at the percentage of them that developed ADHD. And they saw that this percentage was higher than this percentage, which certainly isn't good for smoking. However, we got to be careful about using this word cause. The idea here is that there's a lot of other variables that may have influenced or caused the increased likelihood of ADHD. For example, think about the type of mother that smokes during her pregnancy versus the type of mother that does not smoke during their pregnancy. I don't think it's too much of a stretch to say that if you're smoking during your pregnancy, you're maybe not going to the doctor as often. You're maybe eating different foods. You also might be the type of mother, on average, I'm trying not to be judgy here, but on average, the type of mother that smokes during the pregnancy might raise their kids a little bit differently. They might have different levels of nurturing. They might care for the child individually. The type of person that does this is different than the type of person that does this. So how do we know if it's the smoking and the lead that caused the increase in ADHD, or if it was one of these many other factors that are different between these types of women and these types of women? Okay, so not an experiment. So what is an experiment? Why wasn't it an experiment, and how would you do an experiment? Can't prove causation. So I guess I'm not exactly sure about the order of my notes here. I apologize for that. But an experiment, just go down to the bottom here, the definition of an experiment. An observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. That's what they did, an observational study. They just observed what was going on. An experiment deliberately imposes treatments on individuals to measure their responses. So in an experiment, you impose treatments on the experimental units or the subjects of the experiment. If we wanted to do an experiment, we would take these 4,700 people, families, and we would force half of them, and maybe 2,350, to smoke, and the other half we wouldn't let them smoke. That means doesn't matter what their previous smoking habits were. These people have to smoke. These people cannot smoke. Okay, so now you have people that do different, some of these women are going to be in this group, some of these women are going to be in this group. Now, if you see a difference in the responses, you can attribute it to the fact that you can attribute it to the smoking or the not smoking. It kind of lets you see if this is if the smoking is the cause, or if it's these other factors that we discussed. Okay. Now you could never do this experiment, of course, but that's how you would run an experiment. That's how you would show causation. A properly designed experiment can show that this is causing a variable is causing a change in a response. And if you don't run a good experiment, then you're not going to really know if it was the variable you're talking about or if it's some other variable. So sampling or observational studies, we're trying to estimate a population parameter. That's what we're doing when we're doing sampling. We conduct experiments to try to assess whether changes in one variable cause a change in the response variable. Okay, that's what we wanted to say in this study. But I don't think they ran an experiment. Not sure what this example is. I need to get that out of the notes. Confounding. Confounding occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. Explain the concept of confounding in the context of the ADHD study. We can't tell if smoking caused increase in ADHD or if other factors associated with women that smoke during pregnancy or other factors associated with smoke during pregnancy, such as diet, parenting skills, nurturing, or medical visits. Like, do they go to the doctor as often? Do they take vitamins? I mean, there's any number of variables. Now, I know what you might be looking at this and saying, well, so you're assuming that just because a mother smokes during pregnancy that they're also going to have bad parenting skills and they're not going to eat right and they're not going to be a nurturing mother and they're not going to go to the doctor and they're not going to take No, I'm not saying that. But on average, the type of woman that would smoke during pregnancy might be, you could make an argument, I don't know, might be more likely to do some of these types of things differently than a mother that doesn't smoke. Regardless, whether you think that's true or not, the possibility exists. And therefore, we can't really be certain whether smoking is causing the increase in ADHD or something else. These variables are being confounded with smoking. So I can't draw a conclusion. Is there any way to prove smoking causes ADHD? Run a proper experiment. However, in this case, we can't run an experiment. We can't do an experiment on women and force them to smoke and put their future children in possible harm's way. So there are some ways to do this actually, but in this class, if you don't do an experiment, you can't prove causation. Okay. What isn't a proper experiment? I think we talked about it here. You need to impose treatments on the individuals randomly. So we're going to spend this entire chapter talking about how to conduct a proper experiment. Okay. So let's just identify whether these are observational studies or experiments. If it's an observational study, think about how it could have been made into an experiment if possible. That's not really a question. It's just a statement. Researchers looked at records of 2,500 children who are participating in a long-term health study. They found that students who watched TV at the ages of 1, 2, and 3 years old had a higher chance of it having an attention disorder by the age of 7. So it's kind of a similar type of thing. If you watch TV, does it increase your chances of developing some kind of attention disorder? So the question you got to ask is, did they take these 2,500 kids and impose treatments on them? Say, you watch TV, you don't watch TV. Or did they just observe how much TV they watched and see what happens? This is an observational study. Could you run an experiment? Yeah, we just talked about it. I guess you could. It would be very difficult, but you could. You'd have to find willing parents, divide them into half, force half of them to watch TV, and not let the other half watch TV and look at ADHD down the road. That would be a very difficult, very expensive experiment. Researchers at Stanford University surveyed 4,000 adults and concluded that internet use leads to increased social isolation. Again, part of me wants to say, well, I don't really know. They don't give us enough information. But they looked at adults and they looked at their internet use and they probably gave them some test on social isolation. Again, excuse me, did they give internet and no internet as treatments? Did they take half of the people and say, you guys have to use the internet, you guys can't use the internet? It doesn't really say, but it doesn't sound to me like that's what they did. I'm thinking this is probably an observational study. Could you do an experiment? Sure. Observation, a study involved 200 patients. Half were given vitamin supplements. Okay, so now we're going here. Half were given vitamin supplements for 6 months. The other half did not receive any vitamin supplements. Researchers recorded whether the patient got a cold. Now we're doing an experiment. They're imposing a treatment. They're taking half and they're given vitamins. They're taking the other half and no vitamins. Now we can look at the percent that get a cold and the percent that get a cold. And if the no vitamin group is 60% get a cold and the vitamin group is 20% get a cold, if these numbers are significantly different, then maybe we can say, you know what, vitamin helps prevent colds. Okay. That's how an experiment works. But not only do you need to do an experiment, you need to do a proper experiment. And we'll talk about what that entails here in a little bit. Let's go through some definitions quickly. Vocabulary of experiments. A response variable is the variable that measures the outcome of the study, or the outcome measured. In this case, it was whether you got a cold or not. That would be the response. Yes, I got a cold, or no, I didn't get a cold. That's the response variable. Explanatory variable or factor. This is a variable that helps explain or predict the changes. In this case, whether we gave vitamins or no vitamins was our explanatory variable. Amount of vitamins was the explanatory variable, or the factor. Level. This is the specific values of the experimental variable. So this would be vitamins. Here would be no vitamins or 20 milligrams of vitamins. Those would be the levels of the explanatory variable. Experimental units. These are the smallest collection of individuals to which the treatments are being applied. In this case, we were giving them to humans, so those would be the experimental units. If you're doing an experiment on humans, we call them subjects, so as not to offend them. We don't, you're the experimental unit or you're the subject of the experiment. This is sounds a little better, I guess. But they mean the same thing. Treatment. Specific condition being applied to the individual in the experiment. So in this case, the treatment was no vitamin versus 20 milligrams of vitamins. So you might say, well, treatments are the same as the levels of your experimental variable. The treatments are the same as the levels of the explanatory variable. That's true if you have one factor, if you have one explanatory variable. However, if you have multiple factors, then the treatments might be different combinations of different levels of the different variables. So treatments are different combinations of the levels of each factor. If the treatments make up every possible combination of the levels of all factors, and perhaps a control group as well. Okay, so I think this might hopefully be a little bit clearer as we look at an example. So let's look at the growing tomatoes example in the next video.